Hey everybody, Mr. Burrell here, and we're gonna talk about some basic two-step equations. So yesterday we did some really basic one-step equations, and there's not really a way to do a complicated one-step equation that I know of. But what we are gonna do today are some basic two-step equations, and then tomorrow we'll start making those two-step equations just a little bit tougher. But if you can really nail down these questions here, you should be fine on tomorrow's video as well. So let's go ahead and jump right in with these level 1 questions. Now, if you're watching this video, I'm assuming that means that you're struggling. And if you're struggling, I'm going to recommend that you use the box of doom method. And again, I know some of you struggle with that, but it really is the best way that I have found for students to get on board with solving these equations for these letters. So that's the method I'm going to be using in this video because it's the one that I've seen the most success with. And the more you push yourself to use it, the better off you're going to be. So we have some really simple questions here in level 1. And not only do we have these simple questions, but I even tell you how to solve these questions with this big hint here. So these hints are great, and I'm going to let them stay there. But I'm also going to use the box of doom method as if those hints weren't there. So for question 1, we are told to solve these equations for x. Okay, so it says, follow the steps listed next to each equation to find the value of x. Anytime we're told to find the value of something or to solve for x or solve for y or whatever, I always draw a box, and it's called the box of doom. So I'm going to do that right here. And then I also, at the top of the box, and you'll see why later on this unit, I will put the letter of the thing that we're trying to solve right above it, just to remind myself. Because what's going to start happening later this unit, and especially this year, and oh my gosh, so much in high school, is that you're going to have a lot of different letters in the same equation, and you'll be told to solve for one of them. And it's easy to forget which one you're being told to solve for. So I can put a little x there. And then the next thing I do is I find that x in the equation. And there it is right here. And what I do is I kind of start at the x, and I imagine moving farther away from the x. And I kind of write down the numbers that I see closest to it. What I mean by that is, if I look at this x, this 4 is right next to the x. It's kind of cuddled in there. So I'm going to write the number 4 here. And then I need to ask myself, what is the operation happening here? In my last video, I kind of reminded you that if you don't see a sign, like if you don't see a plus, minus, divide, or multiply sign between two things like this, you can assume that they're being multiplied. So the first thing happening to x, the thing most close to it, is it's being multiplied by 4. And after that, as we move farther away, you can see, kind of move this direction, it's also being added by 1. So this is just where we're listing what do we see. Okay, this is what we see. Just writing exactly what I see in the equation. We have the letter x that is being multiplied by 4 and added by 1. Now, the reason why I like to write down what we see is this is going to be our roadmap for how to solve this equation, how to get x by itself. And the way we're going to do that is we're going to start at the bottom of our list, work our way up, doing the opposite operations. I say we're doing the opposite operations backwards because we're starting at the bottom of the list. So looking at this, again, I'm going to start at the bottom of my list, and at the bottom of my list it says plus 1 right here. So if I want to undo that plus 1, that means I need to do the opposite operation. And the opposite of plus 1 is minus 1. So I'm going to subtract 1 from both sides of my equation. Some students, it helps them to draw this line down here and to realize anytime I do something on one side of that line, I've got to do it on the other side of that line too. Alright, so that just took care of this step here. Oh, I got halfway through. Sorry, Mrs. Fife just barely came in and totally interrupted me. Why don't I finish this step? Okay, so we're going to have 4x, and then a positive 1 and a negative 1 is 0. And we still have equals, 5 minus 1 is 4. Alright, okay, back to normal. So we took care of the plus 1, now we want to take care of this times 4. Well, the opposite operation of times 4 is divided by 4. Divided by 4 like that. And, oh, I wanted to do that in a different color. divided by 4 divided by 4. And that's going to leave us with, well, 4x divided by 4 is just 1x, or we can just write x, equals 4 divided by 4 is just 1. So we took care of that right there, and our answer is x equals 1. Now, I'm trying to have my students always double check their answer, because it also helps them understand what the heck we just spend all of our time doing. Our claim is that x equals 1. That when x equals 1, both sides of this equation are balanced. They're the same number. So let's try it out. If I take out the x and put a 1 in its place, let's see what happens. Well, 4 times 1 is just 4, and 4 plus 1 is 5, and we ended up with a 5 on both sides. So our answer totally checks out. This is the right answer. And I don't know if you noticed the order that we did those things, but did you notice that we subtracted 1 first and then divided by 4? So these hints were good. I mean, they told us what to do, but at least in this video we were able to understand why the heck we were doing what we were doing. So let's go ahead and do that again over here on number 2. We're still solving for x, so what I'm going to do is I'm going to draw a little box of doom. I know I'm trying to get x by itself, and so I'm going to go find my x, and it's right here. Now, this can be a little tricky. Sometimes people ask, well, which is closer? Is this 4 closer, or is this 1 closer? My answer to that is, in this example, because both the x and the 1 are on top of this fraction, I kind of imagine as that's like a barrier. So the closest thing to x here is that it's being added by 1. So I'm going to jot that down. X is being added by 1. That's the first thing I can see. And then the next closest number is this 4. The question is that adding, subtracting, multiplying, or dividing? Hopefully you remember by now that this line here means that it's being divided by 4. Okay? So, Box of Doom tells us that we're going to do the opposite steps backwards. I always draw this arrow to help me remember that. Now, the opposite of dividing by 4 is going to be multiplying by 4. I want to multiply this whole big thing by 4. Now, if you'd like to come into Bear Time to understand more about why this works the way that it does, I'm happy to show you. There's a really long way to understand this. I just don't want to use your video time doing that kind of a thing. So when I multiply this whole big fraction by 4, these 4's are going to kind of cancel each other out. And it's going to leave us with an x plus 1 equals 5. Okay? Again, I'm totally happy to show you that's not something magical. There's a reason why that happens the way that it does. It's just several steps. Yeah. Okay, so we just took care of this step here. Let's go ahead and look at that plus 1. That's right here. And the opposite of adding 1 is subtracting 1. Oh my gosh, hold on. I need to rewind. What am I doing? I'm a big dumb. When I multiplied this side over here by 4, I also forgot to multiply this side by 4. Because remember, anything you do to one side, you have to do the other side. So 5 times 4 is 20. Sorry, it's the week before school is starting as I'm making this video, and people keep popping in and out asking for help, and I keep getting confused. Alright, so now we've multiplied both sides by 4, and now it's time to subtract 1 from both sides, because that's the opposite of adding 1. And our answer, well, x plus 1 minus 1 is just going to be x equals 20 minus 1, which is 19. So, in theory, that should be my x value that balances both sides of this equation. Let's just double check really fast. If I take out this x and put a 19, let's simplify that. Well, 19 plus 1 is 20, and 20 divided by 4 does equal 5. That's awesome. We just found our x value. Okay, so I'll also point out, notice that the first step we did was we multiplied by 4, and then we subtracted by 1. So I have these hints here, but since I'm going to take those hints away, I didn't want to rely on them too much. So what I'm going to do for the rest of this video is I'm going to answer these questions over here. I'm going to answer this side of this worksheet. And I'm just going to do the same thing. It says find the variable. And the reason why I don't just say find x is because each equation has like a different letter. And so that's what we're going to do. So here we go. Question 4. I'm going to draw my box of doom. I'm going to look at my equation and see, okay, well, which variable am I solving for? Well, I'm solving for x, so let's label that right here. Okay, start with the x, so let's find the closest number to it, and it looks like it's this 3, and so I know that x is being multiplied by 3 first. Again, I know it's multiplication because there is no sign written here. There's no plus, minus, or divide. They could have put a multiplication sign, but the reason why they usually don't is because, look, 3 times x. That gets really confusing. So it's really common to just leave out that multiplication sign when you want to multiply a number in a variable. Okay, so 3x, and then we've got minus 4. Sweet. Let's just do the opposite stuff backwards. Let's see if I can do this without making a dumb mistake. We'll see. Okay, so the first thing I need to do is the opposite of subtracting 4. I'm going to oh my gosh, I'm going to add by 4 on both sides, just like this. And these 4's right here are going to add to give me 0. And that's going to leave me with 3x equals 11 plus 4 is 15. That took care of this step right here. Now the opposite of multiplying by 3 is to divide by 3. So x equals 5. Because 15 divided by 3 is 5. That took care of that step right there. So in theory, my answer should be 5, but it's really good idea to just double check, make sure you haven't made a mistake somewhere. So I'm going to go ahead and take out that x and put a 5 in its place. And let's see, 3 times 5 is 15. And 15 minus 4 is 11. We got the same number on both sides, so we know we are doing the right thing. X equals 5 is our answer. Okay. Okay, let's go ahead and start question 6. It looks like I tried to play a trick on you. We'll see if it worked. So, first thing I'm going to do, let's go ahead and make our box of doom. I'm going to look at my equation here, and the only variable is b. That's our thing that we're trying to find out. So I'm going to go ahead and label this with a b. Now, we're kind of used to seeing the x number first in these different examples here, or the variable. But here I kind of put it second. But don't forget, the idea is the same. That's why the box of doom is awesome. So even though we've got this barrier here, the closest number to b is going to be the 7. Don't just write the first number you see. It's the one that's closest to the variable. So the first thing happening to b is it's being multiplied by 7. And then after that, as we move farther out, it's being added by 5. We're going to do the opposite steps backwards. So that means the first thing we need to do is subtract 5 from both sides. So that leaves us with 7b equals negative 7. Negative 2 minus 5 is negative 7. Okay, that takes care of that step there. And then our last step is to divide both sides by 7, because that's the opposite of multiplying by 7. 7b divided by 7 is just b, equals negative 7 divided by 7 is negative 1. So in theory, b equals negative 1 should be the number that balances this equation. Let me just jot that down over here. So b should equal negative 1. That's our answer that we're claiming. Let's just double check. 5 plus 7 times negative 1, oh my gosh, that's ugly, equals negative 2. Now don't forget your order of operations, your PEMDAS. You have to do your multiplication before you can do your addition. So this is going to be 5 plus negative 7 equals negative 2. Put these together, 5 and negative 7 is also negative 2. We got the same number on both sides, so we know that this is the right answer. Woohoo! Alright, let's go ahead and do question 8. Question 8 is just like question 2. So here we have an r, that's the variable we're solving for. The closest thing to r, remember this is like a barrier to start off. The closest thing to r is going to be this plus 4. So the first thing that's happening to r is it's being added by 4 and then divided by 9. So what I'm going to do is I'm going to start by multiplying both sides by 9. And this is another one of those things where I'm going to tell you that these r's or these 9's cancel out, and if you would like to see why that is, if it's going to help you understand how to solve these questions better, you just let me know. And come into bear time, I'm happy to help you with that. So we'll have r plus 4 equals negative 54. And then for our next step, we'll go ahead and subtract 4 from both sides. So r equals negative 58. That is what my answer should be. Let me just double check that over here. Negative 58 plus 4 divided by 9. So negative 58 plus 4, that's going to be negative 54 divided by 9. And yep, negative 54 divided by 9 is negative 6. So we got the same thing on both sides. We're in good shape. Alright, question 10. Ooh, question 10 I'm going to try to trick you just a little bit. So question 10, we're going to solve for C. And this time if we look, even though I kind of said before this is acting like a barrier, that's because both of these things were on top of the fraction. In this example, C is the only thing on top of this fraction. So the first thing happening to C is it's being divided by negative 6. And after that it's being added by 8. Remember, we always write what we see, and then we do the opposite. So I'm going to do the opposite operations backwards. Let's start by subtracting 8 from both sides. So C divided by negative 6 is going to equal 3. So 11 minus 8 is 3. And that took care of this step here. Now we're going to multiply both sides by negative 6. And our answer that I'm getting is that C equals negative 18. Alright, and let's just double check one more time. So if I replace the C, if I substitute that in with a negative 6, negative 18 divided by negative 6 is a positive 3. And a positive 3 plus 8 is going to be an 11. That's awesome. Yep, C equals negative 18 is the right answer there. Alright, let's go on to the next page. I'm only going to do a couple on these level 3s. And I'm going to count on you to do all the rest of those level 2s by yourself. Okay, so the first thing I just want to point out about these level 3 questions, and remember in my videos I don't do that many of them, is that a lot of these answers are not nice numbers. They're fraction answers. That's why it's level 3. But you are a level 3 student. You can handle it. But what I wanted to do is to do question 13, because I intentionally made 13 kind of tricky, and I wanted to talk about it. So, looking at question 13, the thing that I see most common, and I'll kind of go through this quickly because if you're doing level 3 stuff, you can handle it. I'm going to do my box of doom. It's really common for students to say, hey, there's x, it's being multiplied by 3, and subtracted by 5, because they see this subtracting and this 5. So let's go ahead and solve it with these assumptions, and I'm going to use that as an example of why it's so important to check your answers. So we're going to do the opposite steps backwards. Let's start by adding 5 to both sides. Oops. Well, already if you add 5, 5 plus 5 is going to be 10. So we didn't eliminate anything. So that should be your first sign. Whenever you take these steps, you should be getting, things should look more and more simple. But let's go ahead and pretend like, oh, okay, you subtracted 5 in your mind, and so you've got 3x equals 17. Oh, do you know what? Do I even want to do this? This is going to be messy. Let me divide by 3, and x is 17/3. Okay? Well, let's go ahead and erase this stuff. And again, I'm going to be doing some kind of advanced math just to show you, just to get through this part quickly. I'm going to check my answer. Okay, well, 3 times 17/3 ends up being 17. So this is 5 minus 17 equals 12. And 5 minus 17 is negative 12 equals a positive 12. But we need the exact same thing on both sides. So let's just go ahead and erase that, and I'm going to give you guys a trick. Anytime when I'm looking at my variable, if I ever see a minus sign right in front of it, it's just always easiest for me to make that a plus negative. Now, the reason why I can do that is, for example, if you look at 3 minus 2, what I'm trying to tell you is that 3 minus 2 equals 1. And also, 3 plus negative 2 equals 1. And you can double check that in your calculator if you want. But something that we're going to do over and over and over again is to go back and forth between writing a minus sign and a plus negative. Just because sometimes one is easier to use than the other. Like in this example, it's just easier to think of this as a plus a negative 3x. Okay, so let me go back to my box of doom here. Now when we look at what's happening to x, it's being multiplied by a negative 3. And then it's being added by 5. So let's go ahead and do those opposite steps backwards. We're going to subtract 5 from both sides. So negative 3x equals 7. And now let's divide both sides by negative 3. Oh, okay, this is interesting. So in this example, x equals negative 7/3. But I kind of warned you that fractions would be coming, so we shouldn't be too shocked right now. But let's double check. I just think it's always important to double check. So we're going to have 5. I'm going to call this plus negative 3 times negative 7/3 equals 12. And you can use your calculator if you want. I just happen to know that negative 3 times negative 7/3 is a positive 7. And 5 plus 7 is 12. We did get the exact same thing on both sides of that. So that's awesome. There's our answer for number 13. Okay, I'm going to let you do the rest of these ones on your own. I'll just help you do this. So one really important thing that we've been doing in class is translating back and forth between math language and English language. We just go back and forth as often as we can. And so the reason why I point that out is that's kind of what I'm asking you to do here. Question 17 asks us to write an equation of this situation. So we're trying to write an equation of this situation here, and the answer to that equation should use the letter M. In other words, it's just asking us to write something like we see up here. We're going to use the letter M. Okay, so let's look at the story. A checking account is set up with an initial balance of $4,800. Initial means starting. So we are going to start off with $4,800. And then it says $400 is removed from the account each month. So in other words, we're going to lose $400, and it says each month. So in other words, like if it had been 3 months, we could do negative 400 times 3 to figure out how much money had been removed at that point. Or if we did negative 400 times 10, that would tell us how much money had been removed after 10 months. So what I'm going to do here is I'm going to put an M right here. In other words, that means we're going to take negative 400 and multiply it by the number of months, and that's going to tell us how much money we've been removed, or has been removed from the account, from the 4,800 that started there. But it says we need an equation. So let's look here. Write an equation whose solution is the number of months, M. Okay, we got our M. It takes for the account balance to reach 2,000. So in other words, we know that we started with 4,800. We're going to subtract $400 each month, and we want to know when does that equal $2,000. All right. Now, I don't help on level 4 questions on these videos, but I'm going to wish you best of luck, and I hope, sorry this video is kind of long, hopefully it gave you a good foundation on things that will happen in the next video to come. All right, I'll talk to you guys later. Bye!